IT core at the Department of Biomedical Informatics at the medical school. What was that? Was someone trying to say something?
I think just that we started the recording, Nathan. Sorry for the
Oh,
interruption.
okay. Oh,
Sorry for
sorry.
that.
I just heard something in the background. Anyway, so Dan and I have known each other for quite a long time. Aside from our shared work interests, I think if prying eyes look, they would find our Slack conversations riddled with common cause around parenting young children, home ownership, sometimes failed do-it-yourself renovation projects, things like that. Prior to joining the department, Dan was a systems engineer at Draper, where he boldly claims in his profile that he sent sensors to other planets in the solar system. I'm not sure what that's about, but he could speak to that. At DBMI, Dan has played what I think is a pretty critical role in the department's growth, managing a team of full-stack developers who are building and deploying a number of grant-funded user-facing data collection and aggregation tools, many of which have a fairly considerable compliance and security posture. Given the most of those components for these projects are deployed in AWS, thought it would be a nice idea to have him come and offer his perspective on where cloud computing can really fit in the sort of academic IT puzzle. I'll let him say more about his specific projects, but suffice it to say that from my perspective, the projects he's working on with Zach and Paul and the others at DBMI are really one of the most innovative approaches I've seen to patient engagement, community building, and personalized healthcare. So with that, Dan, round of applause. I'll let you take it away.
Thanks, Nathan. That was awesome. I've forgotten about more of stuff that you mentioned there than I've done so previously. The other sensor, the other planet, the Draper thing, I'll just touch on that quickly. That was a chemical sensor that we sent to Mars on one of their missions way back when. If you ever saw the news when they did that, the lead at Tufts was talking about the soil was good for growing asparagus, and so that kind of became a meme. That was one of the nitrogen was in rich supply, I guess, and so that's good for planting asparagus if anyone ever wants to do that on Mars. But that's taking me back. So thanks, Nathan. That was very generous. Thanks, I appreciate that. So I will jump in. I think what I'm going to talk about today, unless anyone has any questions before I go in, is I think I'm just going to review the cloud operations that the Department of Biomedical Informatics we manage in, across our entire portfolio of projects. And so I've got some quick slides here. I'm going to keep it. Can everyone see these slides well? I'm going to keep it in this format so that I can have my notes up next to it while I speak.
But it looks good to me.
Yeah. Okay. So who we are. As Nathan suggested, I manage a small team within the Department of Biomedical Informatics, within DBMI. We're all full stack developers. And so this list is not very long. We've grown to as big as many as 6 over the years. And then recently we've shrunk down and we've started to distribute software engineers across project teams. So there's 2 others that I want to highlight here that are not listed. John Carmichael and Ian Donlan, they were recent hires to take over development on the UDN, the Undiagnosed Diseases Network, and I'll talk to it later. But it makes sense for that to be a separate entity, and I will highlight the project itself. But from like an administrative and management perspective, they are not within the tech core. As much as we have a close working relationship with them, they're not directly within the tech core. So the tech core is myself, as Nathan pointed out, Brian Larson, who is the associate director. He's also a trained software engineer, and he's the lead for our people-powered medicine efforts. Alex Pickering, who's also a trained software engineer, and he's the technical lead for the Selenic software, which I think is somewhat familiar to this crowd. And then where we're looking to grow is to add a new hire that will focus exclusively on security and compliance. We found that effort in the last 2 years has become an increasingly task-driven area. And so we've got a lot of dashboards and we don't have nearly enough eyeballs to manage all the data that comes in for keeping up to date with the new security requirements, and particularly the new compliance requirements that are coming out of HMS-IT. So just a quick anecdote. So I think in 2020, February of 2020, we had a data breach in the UDN and the Undiagnosed Disease Network. And I'll go into more detail there, but that kind of was the first instantiation of how do we do better with security in the department and then in HMS. And it wasn't long after that that HMS had their own data breach for the Office 365. And so that led to a lot more effort of how do we really want to spend time building up policies and building up practices to make our security posture just much more robust. And so as much fun as it is to build software and deploy stuff to the cloud, it requires us to be extremely vigilant in maintaining the security here. As I've noted here, we've got some close collaboration with other development teams throughout DBMI. The CGAP team, the Clinical Genomics Analysis Pipeline team, the UDN, which I talked about, the Undiagnosed Disease Network, Picture, which is one of Paul Aviak's teams, and then there's a bunch of others that I'm forgetting already. But I'll pause there if anyone has any questions about our team before I move on. I am not monitoring the chat, so if anyone sees any chat questions come up, but certainly I'd like this to be a conversation.
I will keep an eye on the chat. I'll keep an eye on the chat, and if there's anything urgent, I will try to interrupt you. Otherwise, we'll save them to the end.
Cool. Yeah, definitely this is a conversation. So if you guys have, certainly chime in and ask me questions in the middle. So what we do, there's three main areas where we spend our time. Obviously, application development. We're all full stack software engineers. This is where we like to spend our time. We mainly build REST APIs. So deploying databases in the cloud, storing metadata, making queries against that data. This is support. These applications are in support of projects like the UDN, like the PPM projects, where we want to create portals that folks can submit data. We can collect it, we can aggregate it, and then we can provide tools for principal investigators, for other researchers to access that data. And that goes with the caveat that we need to make sure we manage the access controls and we need to keep the data secure. Right, so the data can come in any different types of forms. It can be flat files, it can be data that we store in databases, and it can be, the access can be through a UI or it could be through a command line tool. We hesitate, although we've done this in the past, to give folks direct access to AWS. Typically what we like to do is we like to have a management layer in between there. So that's usually the REST API. But for the most appropriate situations and where it does make sense, we will grant folks access directly to AWS. So only as it makes sense. So the other half of the work is the next two bullets there, but I've broken those out into two parts. So we kind of manage the cloud operations, and that includes largely the security and the compliance of all these projects. We help with all the projects that live in the cloud within DBMI. But then the ones that are most closely related to us, the UDN, the PPM, those are ones that we actually touch. And so I'll go deep a little bit on those projects today and show you guys some of the infrastructure and some of the technology that we've used there. And then the last area is in the cloud operations, is where we're supporting new cloud development. And so this is where we have a project that is similar to what we've worked on in the past, but it's different enough that we want to use, say, a new cloud tool that's offered up. So PPMG, so People-Powered Medicine Guidance, is an example there, where that is exclusively using serverless technology. It's based on an Apple iOS app. And so there's a direct connection between the Apple apps, between apps on people's phones, sending data directly to AWS Health Lake, which is a Firestore. And so that's something new that we've never done in the past. I won't highlight that too much in detail today, but I can direct folks to more information if they're curious about that, or even to Raheel Saeed, who's the lead developer on that project. And then the other one that I will highlight is the UDN joint analysis. And so that one was a new kind of application development that wasn't a REST API, but took advantage of a lot of the batch processing tools that are available in AWS. So I like to think of it as a data center on demand. So as we want to do the processing of the UDN samples, the realignment, we launch our own data center and we process the samples and then we shut it down as soon as we're done. And so it's very kind of ad hoc, but as I'll highlight later, the cloud can be expensive. And so it's not always the best choice. And so I won't advocate that you use the cloud, but when it makes sense, I think it's a very useful tool to have at your disposal. The landscape that we work on right now, it's really kind of narrow. I mean, if we think about all the work that DBMI does, this really captures where we're operating in the cloud. The top three, Aviak Lab, Park Lab, and Raj Prakar Lab, they, I won't talk in any detail about what these projects are, but suffice to say, they do operate in the cloud. And so from a scientific perspective, I don't think I know enough to really even do them justice. But from a security and compliance perspective, I work closely with the developers in these labs to make sure that what they are doing does stay secure. I think for this, the only ones that are level 3 data security or above are the projects in the Aviak Lab. So Biodata Catalyst, and some of the picture stuff. And even there, I think it's not AWS accounts that we manage directly. It's accounts that are managed by other folks. But those projects still need to have a high level of security applied. The ones that we do manage, the Undiagnosed Disease Network, the People-Powered Medicine, and even the Selenics, and some of the DBMI data portal, those are data security level 4 at least. And so we've applied, for UDN, we've at least tried to model some FISMA moderate security controls. But because of the way that that project is structured, it's an internal review. And so it doesn't have the rigor that we would have if we were to do a proper security review with the third-party audit and all of the expenses that go with that. So that's kind of a gross overview of where we spend our time. And so I think from here, I'll go deep on some of the projects, unless anyone has any questions. No. So the first one I want to talk about is the landing zone that we've stood up. So this solved a big problem because we had a lot of growth in the department and we needed a lot of AWS accounts. And as we started to grow, working with AWS directly, best practices was to isolate all project work into its own account. And so this goes as far as to say is that every project should have at least 2 accounts. So one for development and then another one for production work. And so the benefits there of completely isolating your development environment from your project, from your production environment, is that you can do things in your development environment at a lower data security level, and you can test them out to see if how access really can be managed. And this, so this gives us the ability to completely isolate our project work. We can vend accounts very easily, vend new AWS accounts very easily through this, and all those new AWS accounts come with baseline of security controls of monitoring and logging. So that's beneficial from the perspective of we can always track what users are doing within the AWS accounts. And we've set up some baseline alerts so that we know when users are stepping outside of their boundaries or when they try to do things that normally aren't allowed. And really what this does is it simplifies the process really of isolating all this project work, right? I think we built this as an outgrowth of some of the work that Paul Aviak did. We don't want to do this in the future because it's a lot of administrative overhead. It requires that we go in and we maintain user access. One of the plans for the future that we have for this is to tie it into Active Directory, HMS Active Directory. We don't have that there yet. HMS IT wasn't ready for some of the things that we wanted to do. And we needed to get going quickly. And so we prototyped this very fast. We're using it, it's in production. But there's a lot still of administrative work that's required for this going forward. So I think as we continue to grow, we're continuing to work with HMS IT in order to get their buy-in and get their support in terms of manpower for managing these AWS accounts going forward. This is just a quick picture here that shows you some of the account structure that we have. At my last count, I think we had over 84 AWS accounts in our landing zone. And so you can imagine, I think, with all the users managing access to all the different their accounts, it just becomes a question of scale. And with only 3 of us managing this, it really becomes kind of a burden.
So Dan, question for you. Is an account here a person? Is it a role? Is it a project? What's the scope of an account?
It's an AWS account here is an actual, I mean, it's a one-to-one, it's an AWS account. A user is very different. So a user account is totally isolated, and users can have access to multiple accounts, multiple AWS accounts. And then they can have different roles within those AWS accounts. So does that kind of answer your question? I think users are totally separate from this.
So an account is a billing construct, as it were, an administrative construct that sort of sets VPC boundaries. You know, if you were to enable some private space within that public cloud environment, the account would be the administrative boundary around that. Individual users are then allowed particular role on a particular account.
Yeah, I think that's the best way to frame it. Is it's a billing construct. Is really what it is a billing construct, because even within these accounts, you could have multiple VPCs.
Sure.
And so you could have complete isolation within the accounts there. Ludwig, I see you got your hand up. Yeah.
Yeah, sorry that I take you the liberty to ask a question in the middle of the talk, Dan, but I think this is how you wanted. Just like for the general understanding as a new user, where would I find that? Is there a URL that is somehow like linked on the DBMI IT page? And I guess, is this then the landing page where I would land as a user once I'm logged in? Is this how it works?
No, so we haven't advertised this broadly, and there's no publication yet that shows how you get here. There's plans to do stuff like that. We've got it in the works for a while. This is all managed through AWS, through Okta. And so from here, I can take you guys on a quick tour of the dashboard. We have an administrative, oh good, I do have my phone. This is how group management and access to all the accounts is currently administrated. And so users would need to go through us, through myself, through Brian, or through Paul Aviak in order to gain access directly to any of these accounts. And so within here, I mean, the groups is bigger than the users because users have access to more than one account, but the groups is how we manage who has access to which of these accounts. And just the CGAP team is one of the biggest teams here. These are all different roles that CGAP users can access across all the different accounts that they have. And so a lot of these are admins. So I think that's where it gets again to managing privileges is we can manage privileges as granularly as possible within AWS, but it requires that connection for now between Okta and between AWS SSO and between AWS permission IAM roles. And that's what drives what permissions they have when users access the different accounts. I don't know if we are going to open this up outside of DBMI, but I think we could if there's interest. I think if you are interested in creating your own AWS accounts and you have a need and you have a billing code, those are the requirements that we need in order to stand up a new AWS account. The billing code is critical because otherwise it goes on to Paul Aviak's credit card. So he'll come for you
I'm fine with that.
Yeah, right.
Yeah.
So.
Sorry, thanks, Dan. Jacqueline here. I'm just wondering about, so in the case of Selenix, that sounds like it would be a really great solution for that kind of situation when we have platforms like Selenix. I mean, it's like the first one that we're putting up, I guess,
right,
sponsoring. But going forward, do you think that this is a solution that could be used for other platforms in the future?
Yeah, I think absolutely. I think so. The landing zone itself is definitely a solution for the future, and the way that they've set this up is the way that you do this multi-tiered AWS account organizational structure, right? And so I think what the landing zone provides is, this is a bit of an eye chart here. If I go into this, what the landing zone provides is it provides a baseline set of accounts for billing, for security, and I'm forgetting the other two. But what those do is those segregate all the tools that you use for management, and it allows you to distribute those tools across any of the child accounts that you then have. The benefits there are that then logging and monitoring all goes centrally located, and so that you as a scientist or a developer, you don't have to worry about standing all that up individually in order to be compliant. Right. And
so when you say account, you mean literally 12-digit AWS accounts, like full top level accounts.
Right. Exactly. Right. Yep.
So in the case of Selenix, like, we're not going to be charging, at least that's not the plan right away. But going forward, if we had platforms where we would need a cost recovery model of some sort for other things, then we could put those here and put that in place.
Yes, I think so. Okay. One of the other tools, and so I'll get to this in the future, actually in a slide or two. I don't know if I have it here. I don't have a slide on it here. The AWS Service Workbench. So this tool, the way that this is designed, is if you have a group of accounts that you don't necessarily own, but you want to share data between those accounts, that's where AWS Service Workbench really shines and provides those new capabilities, right? And so this is, so this is your federated control of access to data, tooling, and compute power, right? And so not everyone, so you don't need to own all the accounts, but through Service Workbench, you can grant accounts that you don't own access, specific access to those accounts that you want to share. So this is the brainchild of Paul Aviak. So he went to AWS and said, Google Cloud has this feature for billing, we need this on AWS. And so he worked with them in order to create AWS Service Workbench. And now they have, so they've launched it as a solution, I think. So you need to build and deploy this yourself, but it comes with the capability of managing like other external accounts that you don't own, giving them access to data that you do own. So that's something to think about.
Yeah, that's great to know. Just thinking, like a few years down the road where we want to head with. But yeah, thanks, Dan. It's great.
Yeah, and this is largely a billing management service, right? And so I think that's where this really helps.
Mm-hmm.
Sorry, if I could jump in with one more question. Are your guys' accounts under the Hewitt consolidated billing arrangement, or do you have a totally separate chart of accounts?
Yeah, so this is all, so we have this, all of this goes through this AWS organization. I don't know if you can see the details here, but all of these accounts that we add to this landing zone, so the DBMI BCH landing zone, they all go into an AWS organization that is connected to the consolidated billing through Hewitt. And so that's why when I said you need a GL code in order to sign up, we enter that as a part of the account vending. And so every new account needs to have a GL code, and then that goes back to Hewitt billing. So it's all centralized and consolidated, and then they can bill appropriately.
Yeah, okay, that's great, because we have one account and we're struggling with costing and access control using tags and a bunch of other stuff. So something like this would be great.
Exactly. Yep. Yeah. So as you want, you can launch new AWS accounts. And so I think I have been instructed by Suzanne to support CCB in this area going forward. And so I think, we should definitely start the conversation. If this is something that you are interested in using and you want to launch your own AWS accounts, or you want to launch new AWS accounts, let's certainly start that conversation. Today would be a great opportunity to kick it off. And then we can administer new accounts for you, as you have projects come up. And then what we are learning about in the future, I would love to transition this off to, say, research computing or somewhere else centrally located, because, I'll go back to my who we are slide. We are 4 people. And so the more accounts we have, the more support that's going to require. And I don't know if we are going to be in the business of doing that long term. So we can certainly handle it now as you're experimenting with how you want to do your AWS account structure. And then I think long-term, we're looking to transition this over to HMS-IT to give, because they would be much better from an operational support perspective. I think I just wanted to highlight here, like, these are the accounts that in the tech core that we've isolated and we manage for all of our projects. There's PPM, all the whatever. These are different flavors of PPM that I'll show off in a little bit. But yeah, these are all great questions. So it's interesting to hear that you guys are super interested in this stuff. So I'm going to now jump into project-specific work. So this is one of the projects that lives in one of the accounts in AWS that we manage. The coordinating center, the UDN coordinating center gateway. And so if you're not familiar with UDN up to this point, so the Undiagnosed Diseases Network. So I think of this, my quick elevator pitch about this is it's crowdsourcing of diagnosis of rare diseases. And so the idea here is that if you have a rare disease, you can apply to become a part of the UDN through the gateway, which is a tool that I'll highlight. And so participants can submit their information into the gateway to become a part of it. And from there, it goes to a clinical review board. They review the applications that come in and they decide either we have a diagnosis or any number of decisions that they can make on there. And so, or, you have sufficient information that we want to admit you to the project. And from there, if you're admitted, you get sent to one of the 22 clinical institutions that are a part of the project, where you get a full phenotypic evaluation and genetic sequencing is done. And then all of that data goes into the gateway. So unfortunately, I don't think any of you are on the IRB. So I don't think I can show you the real gateway. And I don't even know if I have, because the URL has changed. The dev gateway. I don't have it. And I don't know what it is off the top of my head, but I should have had it. But it is a web app that sits at the center here, and it allows for all of the clinical institutions to submit data, browse patient records, and then collect and review all of the information that's submitted about a participant into a single portal. So they can submit for sequence requests, they can submit for metabolomics requests, they can submit for new biorepository samples to be collected. And all of that information is collected in our Django web app that was launched originally in 2015 and is undergoing its like 4th or 5th major refactor now. It lives on an EC2. It talks to an RDS database, and then it stores all the sequencing data in S3. And then through the gateway, we can provide both authentication and authorization to only access the data that these clinical institutions need to access. Right, so we've set up security boundaries around the different AWS resources that isolate them from a network perspective and also isolate them from an access control perspective. I can't say enough about how many diagnoses that have come out of this, because now what they're doing is they're allowing institutions on the other side of the country look at patient data and then provide their insight. And I think that's why I think of it as crowdsourcing of diagnoses for all of these rare diseases. But I mean, from a technology perspective, it's pretty simple. It's a REST API that lives in the middle and has a UI that allows users to submit and then access all the data. So one of the items that's come out of this that I've spent the last 18 months building on is this joint sequencing analysis. And so all of the participants that submitted data to the UDN, it was at various stages, right? And so it goes back as far as 2015. Some of that data that was submitted was aligned to, I don't even know the different reference files, but it was aligned to a different genetic sequence reference. And so now that we have more than 4,000 UDN participants, there has been a big effort recently to realign all of this data to the latest reference, the HG38 reference, and then do some joint variant calling on that data to try to uncover some new diagnoses, from what I understand. So this new system, we developed this, myself, Shilpa Kobrin, and Shamil Suniev developed this system by which we were able to realign all the data using a tool that came out of the Park Lab. So this is a case where I think we were uniquely positioned because we sit at the center of DBMI, that we could pull tools from across the department and put them together in order to do a new application. So Tabana was originally designed as a genomic and alignment step, I guess, tool. And so it was really only designed to do 1 or 2 or say 10 applications at a time or patients at a time. And they were doing these as one-offs. Patients would come in, typically it required that a postdoc or another researcher would babysit the different steps that it needed to go through in order to produce a newly aligned sample, and then to call the variants, and then to create this, the data in a way that you could then do analysis on it, right? And so when we looked at this, and we originally had about 3,000 samples that we wanted to process, there was no simple way to do that. So the cloud, AWS in particular, because I'm a developer and I like building new things, AWS provides all these tools, and it makes it very easy for me to build what I was just creating, a messaging queue. And so I had 3 parts. I had a scheduler for all the samples that I wanted to schedule for the different steps. They would dump those samples, or they would dump those messages into a queue. The processor would just read from the queue, pull the steps off, and then launch those steps onto the AWS data center, up to a certain limit. And then there was a tool that just monitored what was going on with all those steps, and then updated what sat at the center, which was just a REST API, and recorded the status of all the different steps and where each sample was in the various steps for this pipeline. So there was the first iteration of this. We had 8 different steps that each sample needed to go through. And so tracking this through spreadsheets was just a nightmare, which is why the generation of this system really started. And so I know in here, so there's still some automation that could be done, but a lot of this work is still done using IPython notebooks. So as painful as it is, that was the tool that was best suited in order to track the samples, query back to the database to understand the state of each sample as it was going through these various pipeline steps. And really what this did was this had a bunch of challenges. It had a scaling challenge. It had some data security challenges that we needed to overcome. But then the scaling challenge on top of managing the steps or managing the samples through the various steps, there's also some limits on what AWS had available for us to actually do the processing. Because some of the steps within here required some pretty beefy machines, some C5N 18X large, which those are like 72 cores and like 196 gigs of memory. And so because we wanted to do over 4,000 at a time, we couldn't really do that on, say, something like O2 because they just don't have the compute capacity. But even AWS wouldn't have the capability for us to do 3,000 of those at once. And so AWS doesn't publish what they have for their compute capacity, because I guess that's a security concern. So I needed to experimentally determine how many of these jobs I could do simultaneously before they would start failing. And so eventually what happened was I would launch, say, 40 of them at a time, and those all look good. And then I would go up to 50 at a time, and those also look good. And I think I got up to, with the biggest machines, I got up to 60 at a time. And I met with AWS, and they said that that approach was the right approach to do, because their back-end system for how they determine whether or not you're actually able to successfully complete these jobs or use the compute is whether or not you've consumed enough compute previously. So they reward you for being good customers by giving you the ability to spend more money on their systems. And that's just AWS's business model. But this was a particularly fun project because it used one of the simpler software development models that I learned a long time ago as an engineer, as just a consumer and producer. So using some of the tools that AWS has built. I think if I think about this, if I was to build something like this on O2, I need to build up a queue, right? I would need to build my own web server. I'd need to build something that would handle how to manage all these different tasks. But AWS made it pretty simple to launch all these because they provide these tools out of the box. Okay, so the next two slides that I have, people-powered medicine is one of the last projects. And so this is a bit of an eye chart, this diagram here. But this is an evolution of the architecture that we had for UDN, which is just, we've got a lot of compute here, some web servers. We've got some flat file storage, and then we've got some RDS that exist. And so because I say this is the evolution of UDN architecture is because we've broken out all the different parts that the UDN does, the authentication and the authorization. We've broken out the data handling, and we've broken out the registration into small apps. And even we've put them into containers. And so that makes it a lot easier for us to manage the features of those. It makes it a lot easier for us to manage the security of all the individual stuff. And then we enhanced the way that we deployed and these applications to the cloud. So this is nice because it gives us a template going forward for how to run these projects where we want to solicit and collect a lot of data from participants, organize it, and then aggregate it, and then share it back out to the rest of the world. And so this now has, I've only listed 2 projects here, but it has 3 projects that use the same infrastructure. And it is as close to like a single push button deploy for every new application that we have. The one that isn't included here is an autism study that we never got a lot of participants for, but NEAR, which is enigmatic, I forget what the N is for, but it's enigmatic exceptional responders. It's for cancer patients to submit their data. And it's the same idea, it's phenotypic data and it's genetic sequencing data. And it was to try to identify those folks who were cancer patients and survived. Like, was there something specific about their data that identifies them as an exceptional responder? And I think there has been some promise that's been shown there. RANT is one that's just launched. That's for rheumatoid arthritis. And so far we've had 26 participants submit their data. The goal is to get up to 300. But the other interesting thing about these projects is that we are getting data directly from electronic health records. And so we've set up Picnic Health as a service, which does digitized health records. So they go out to the different institutions, they collect the data, the hard medical records, they digitize it, and then they submit it for us. But then we're also doing a collection from FHIR using the web portals. So when participants have data in the cloud, when they have medical records in the cloud, they can submit directly from their clinical institution to send the data directly to our study. So that's FHIR data directly through a product called Procure. And then that goes into our databases and makes it available for those that have access to do research on this. But yeah, I think the highlight here is that we've got now push button architecture deployment that we can, anytime we have a new study or a new idea, we can just create a new system that's completely isolated from the others and then collect their data and make it available for researchers to access. And then what I'll close on is just how security and compliance is paramount to all of this. Because of the breaches that we've experienced in the past and because of the breaches that HMS has experienced, we've gone through a lot of efforts in the last few months, the last few years, to increase our inventory of how we manage servers, how we do vulnerability management across them, and then how we do patching across them. And I think that's part of the reason why using new technology and using more modern offerings from places like AWS is really attractive, is because a lot of the apps that I've shown you, you can now do that completely serverless. And so you don't need to stand up your own compute. You don't need to stand up your own server. You can do their serverless offerings, and then you don't need to manage any of the operating systems or any of the packages that go with that. AWS provides that for you. And so that simplifies our job going forward. The other benefits of working in the cloud, at least from a developer perspective, is we can do our own networking. So if we want to change things around and we want to grant access, it makes it very simple for us to change the rules. I mean, it's a double-edged sword in that sense, is that if we make mistakes and we open up things the wrong way, we are the ones that are on the hook for if anything does go wrong. But AWS does provide a lot more tools now to do security analysis on this. I think our going in position is minimal access, so least privileges for a lot of this stuff. And so typically where we start is no access. We run a lot of our EC2s in completely isolated and private subnets so that no one has access to it. And then we add rules that grant only that access that we need going forward. So UDN is a great example of something like that. SSH is completely disabled. It's behind a load balancer. And so only ports 80 and 443 are allowed web access to the systems. CGAP is another one where there's actually no access to the internet. It uses VPC endpoints in order to access S3 and access RDS. It only allows the instances that need to access the other resources direct access out there. And so there's some real benefits from being able to deploy new applications like that in the cloud. But again, I will say that, you know, as much as I'm an advocate for working in the cloud, it comes with cost of being vigilant and making sure that you do your own security controls. And so that's like the other area where we're spending a lot of our time now, not because we want to, but because we need to, is the security control documentation. We need to make sure that we can verify that we have put all the security in place. And that goes hand in hand with doing policy development. And then also the other part is data safety training. So we need to make sure that all the users that have access to AWS or to administrative privileges on these applications, they have been trained appropriately for, you know, working with any of the data that they need access to. Thankfully, we only have a few that are data safety level 3 and above, but still it requires us to be continuously on task and making sure that only those that do need access have access to it. So I put a quick note in here about new technology because that's an area where I feel like we are going to grow, but the only one there is Fire for so far. So I'll just gonna gloss over that for now. But if anyone has any questions on anything that I've said, I've done a lot of talking and there was a lot of good questions in the middle there. So, but I'm certainly happy to have more conversations about this.
Great, thank you, Dan. Really nice talk, thank you. So I think if people have questions, why don't we use raised hands to cue them that way? If not, I have a couple. Ludwig, would you like to go first?
Yeah, totally. Thank you so much, Dan. That was really interesting for walking us through that. Just out of curiosity, and I think we already touched on that a little bit when you have been there at a CCB meeting a couple of weeks ago. So for us at CCB, where we're doing, at least until here, mainly stuff on O2, I found it very interesting when you said on one of your slides, you know, in comparison to standing this up on O2, it had these and these convenience features. Apparently, there were some tool chains already up there that made the infrastructure and the architecture much easier. On the other hand, I understand a little bit like a downside, or at least there needs to be some extra attention put into security. I just wonder whether you could elaborate a little bit more for folks here at CCB who are doing computing on O2, where this cloud computing comes in and where does it really like benefit over doing stuff here on O2? A little bit like pros and cons.
Yeah, so I've only done a little bit on O2, and so I don't know the full capabilities there. I mean, I think I'll always, Nathan, I'm going to go to you for taking advantage of O2, right? Because I think, as far as I'm concerned, you're the one who's taken most advantage of that, at least as far as I know, right? And my, I don't know, but from an AWS perspective, they are always adding new resources, and so they make it very easy from a developer perspective to create new applications, right? And I don't know what that's like on O2. From a development, from a CI/CD, from a continuous integration and development perspective, I wasn't able to find a simple way to do something like that on O2. Whereas with AWS, it's very simple to stand up a server and create a pipeline to launch updates to new applications.
So would you like me to respond, Dan?
Yeah, go for it.
So yeah, I guess I'd decorate Ludwig's question with a slightly different set of brushstrokes. And that would be, can we think about creative ways to use the sort of off-the-shelf tooling for these infrastructural pieces that AWS provides? It's very low friction to implement the continuous integration, continuous sort of approach to software development and platform development, while also taking advantage of on-prem tools. And what comes to mind is, in particular, with the joint variant calling project, right? All of the things that you outlined in that flowchart, certainly, you know, I've never built them in AWS, but I did sit around on the sidelines listening to you and Brian and occasionally Michael back in the day chat about some of these things. And certainly it seemed like they were relatively easy to plumb together through AWS, and it would have involved standing up, you know, there are standard software packages for doing some of these things, but you would have had to get them stood up and get them talking to each other and sort of. So is there a way to think about using the infrastructural component, the control plane, as it were, the management layer, while calling out back to O2 maybe for some of the high throughput compute that's really, really expensive to do, I think, even as you guys found on the spot market at AWS? And have you guys looked at any solutions like that?
We've started to, so that's where the joint calling is headed, I think. And I think that's because the high performance compute still doesn't make sense to do on AWS. It's just cost prohibitive. I think when I think about some of the systems that you've bought in the past, right, you'll spend like $70,000 and you'll have a system that will last you for several years. And you could very easily spend, I think for the joint calling, in the last 2 months, we've spent $25,000 just on processing these samples. And I just don't think, so that's it. Like, yeah, I mean, it needs to be somewhat of a hybrid cloud solution. And I think understanding where that line isn't necessarily easy, because you need to understand the operational perspective of both systems. Yeah,
and I do think, so from my interactions with HMS IT, we have a number of things that we've bought into our both Azure and AWS subscriptions that make those things pretty appealing, or at least they will be appealing when they become more fully fleshed products. And that is through our private peerings in our data center, we can essentially create an extension of our own private network into these cloud environments. So we're renting someone else's servers. Rather than sending our communications out from O2 over the public internet into AWS, we've got a direct fusion point. Literally, we're plugged into the same switch somewhere, at 1 Summer Street. So our information never goes out over the public internet, encrypted or not, right? It goes directly into the AWS environment. And that is also often confused with the existence of a couple high throughput links that we have into those cloud environments as well. So we've got, I think with AWS and Azure, redundant 10 gig per second connections that allow us to move a reasonable amount of data in a short amount of time.
Yeah, you're gonna have to add me into those that were naive to that, because I assumed that those were the same thing. Those direct connections were similar to the private peerings, but it sounds like they're not.
I think you have to pay extra for the private peering because it involves a whole different management of address spaces, right? I think the fast connection is just a fast connection, but you have to pay additional in order to get the private endpoints presented for the services, right? Because it's one thing to stand up an EC2 and get a 10 dot whatever address on our network. It's another thing to have all that stuff as a service present over that private peering. I think is where the subtlety is. I'm by no means any expert here.
Yeah.
Anyway, let me stop driving the conversation. Tyrone, what are your thoughts? You're on mute.
Yeah. Hi. This is a good overview. I have a few questions regarding endpoints and exposing them, because you mentioned a lot of security and compliance, and that's well within the current HMS team. You want to do that for any collaborators within that, or any customers within that, quote unquote customers. But let's say, do you guys have any plans for being able to expose, let's say you want to expose endpoints to external collaboration, for example, an S3 bucket, but you wanted to use someone else's data set, so somebody has to be uploading or sending data to that. Or in some cases, it's a cost prohibitive in order to invest capital into HPC. You want to seek a collaborator with those resources, or grids, or MIT LL, for instance. Do you have any knowledge on how external collaboration is going to work within this framework within AWS, or do we even have any flexibility within the way that single account in AWS does right there? Because in my experience, you would need multiple accounts to accommodate external collaborators, just so that way you know who's covering what for these shared cloud pools.
I think, I think your best operation is to distribute that across AWS accounts, and then create rules that allow the AWS accounts to talk to one another. But I don't know, I guess I'm not entirely following exactly what you're asking. Secure file sharing for S3, that can be done. S3 has a way to create secure download links that have lifetimes associated with them. But you can also go AWS account to AWS account.
I guess when thinking about some of the other projects right there, there are times where you want to expose endpoints to other areas, so that way they can do compute instead. It's just that you can do permissions for that right there, but most of these times require the data sets being almost completely public, because the way other APIs work.
Yes, so I didn't highlight this, but I worked with AWS a while ago about creating roles. Let me see if I can find a note real quick. Data sharing, across account data sharing. And so I think at one point I will look for that, Tyrone, and let me see if I can I created a wiki about how to set that up, but I don't have it off the top of my head. And that explicitly shows how you have data in one account. And this was the wrinkle that I had, was I had 3 accounts. So the first account was the host account. That's where all the data lived. The second account created the data and put it in the host account. And when that happens, either the host account can be the owner, or the creator can be the data owner. And then they wanted access by a third account. And so the permissions needed to be such that the host account could grant permission to the third account to access objects owned by the second account. And so it was a very kind of permissions spaghetti mess. But AWS, through their permissioning system, we were able to create a solution by which the third account could assume a role that was effectively within the host account and could access all the data that they needed to access.
It's good that you have a pattern for that. I was worried that if we ever run into a wrinkle such as that, we would have to go to yet another service like GovConnect or something Azure does. I know Azure has these intermediaries for external stuff right there, but that's good that it's interesting that you have the pattern. So that'll be useful to know.
Yeah.
Great. Thanks, Theron. Anyone else have any other questions? All right. Well, we are just about at time. So with that, I'd like to thank Dan. Nice big round of applause. We heard considerably less than I expected about interstellar space travel. But nonetheless, it was a really important and engaging talk. Thank you for taking the time to prepare it and sharing with us today. I really appreciate it.
Yeah, thanks for the invitation. This was a lot of fun. It was a great exercise to recap. So
excellent. Okay, everyone. Thanks again, Dan.
Thank you.
Thanks, Dan. Thanks, Nathan.
Thank you.